All right, hello. Welcome, it's good to see so many people back. My name is Allison Bamberger, and I'm the program director here at the Masonry Institute. Welcome to the very first seminar of our 2025-26 season. We're going back to the basics with Masonry 101, designing masonry structures. Got a lot of people in here. Do we have some new faces in here? Raise your hand if you've never been here before. Welcome, I'd love to see some new faces. Take some time, meet some other folks that are here. There's a lot of knowledge in this room. And speaking of which, we also have our staff. We've got Dave Gillick, he's our executive director. Hi, Dave. Next to him, we've got Chase Moorfield, another new face that's in this room. He's our residential specialist. I think this is day 3 for Chase, so yeah, trial by fire here, welcome. We got Greg Bryant with our Structural Coalition. And Bruce Augustine, he is our technical director, engineering extraordinaire. Any of these people can answer any questions that you have about masonry, and we hope that you'll come back and ask. Of course, we also have Phil Ledent here today, and we're so happy that he's come from the Masonry Institute of Michigan to be with us. Of course, today we're going back to basics with designing masonry structures, and these are our learning objectives. You have those right in front of you. We will be giving AIA, ICC, and PDH credits today. Tomorrow, you're going to get a survey in your email that's going to ask you how we did. What did you think of the food? What did you think of Phil? You will see the responses, but you won't know who said it. So you're fine, being honest. But really, that data does help us quite a bit as we plan for the next year. And believe me, I'm already planning for 26, 27. So I want to hear what you have to say. We have some attendance prizes. I'll be passing around a little box. We have a Masonry Basics book. How about that? Very apropos. But also, Phil has given us a Ledent Design Solutions cap, so you'll be styling and educated. What else can you ask for? Ooh, sorry. We want to take a second to recognize the Concrete Masonry Checkoff. They're a sponsor of our season this year. They have the Beauty of Block campaign. You can scan this QR code to learn more about the Concrete Masonry Checkoff and the Beauty of Block. It's just another resource for you all as you're designing with masonry. They've got online learning courses. They've got information from all across the country. They're a great resource, and we thank them so much for supporting us, not only in what we do here, but in what we do at universities and other places like that. So thank you to the Checkoff. And also thank you to MGI Risk Advisors. They're a new sponsor for us this year, but they are not a new sponsor of Masons, and they have been around for 40 years, helping out folks with all kinds of insurance needs, home, personal, health, etc. So give them a call if you've got any questions about insurance. Bill Eads has been with us a long time. He's wonderful. So without further ado, I'm going to give you over to Phil Ledent to talk about Masonry 101. You got a masonry job? Now what?
Thank you, Allison, and I wanted to thank the Masonry Institute of St. Louis for the opportunity to come down here today. As Allison mentioned, I am the executive director of the Masonry Institute of Michigan. We're sort of similar to MISL in that we represent contractors, producers, suppliers, architects, and engineers, and so I've been pretty active in our code since 2012, and oftentimes what I'm doing is just trying to help architects and engineers design efficiently with masonry. In addition to the Masonry Institute of Michigan, I do own a separate structural design business, Ledent Design Solutions. So this is actually our first order of hats since it was just started in February. But I have been involved as the engineer of record on projects in Kentucky, Iowa, Nebraska, Michigan, kind of around the country. And so when Dave talked about, kind of back to the basics, I thought this was a really great topic, especially because I've been bringing in more work and designing masonry structures and just kind of talking about back to the basics. Oftentimes when I work with architects, the benefit of masonry is just how simple our masonry wall assemblies can be and how good they're going to perform over time. So we're going to walk through kind of a job that I just completed. Drawings went out last week in Kentucky. We'll kind of talk about some of the decisions we made, how we got to those decisions, detailing standards, things like that. And a lot of this work is coming through the Beauty Block Concrete Masonry Checkoff program. And so if you do have questions, reach out to them, and they have a list of consultants they can reach out to as well. So we already went through our learning objectives. You can see kind of the building in the background here. This was a gymnasium space. They had office space. They had therapy rooms. And they reached out to us because they didn't think masonry could meet energy code requirements in Kentucky. We were able to kind of walk through that with them. And once I got through that, they didn't have an engineer engaged. And so I ended up doing the work for the project. So we'll kind of talk about how we got from zero to getting those drawings out the door. And so the first thing we do, whenever I look at a job, I'm like, where is it, right? And so this particular project was in Shelbyville, Kentucky. ASCE's done a really nice job in recent years at updating all of their design loads. So you can go on their website, they have a hazards tool that's going to give you everything: snow loads, seismic loads, wind loads, all those sorts of things. And actually, in some of these lower snow regions, such as this, where we had a low slope roof, actually rain loads ended up controlling for some of our joist design because we had to take ponding into consideration. But ASCE makes this pretty simple for us. We can just pull those design loads. And the big thing here is we can identify what sort of masonry system we need. And so in this case, we're in seismic design category C in Kentucky. So if we go to ASCE 7, chapter 12, that gives us all of our different seismic force resisting systems. And so since virtually all of our walls are reinforced today, that limits us to ordinary reinforced masonry shear walls, intermediate, and special reinforced masonry shear walls. Being in seismic design category C, I went to this list, and we were allowed to use an ordinary system up to 160 foot in height. And so that's what we ended up doing for this building. In this part of the country, St. Louis, seismic design category D, typically we're going to automatically default to a special reinforced masonry shear wall system. We'll kind of talk about the differences between these systems just a little bit, so that way we're all comfortable with them. For our ordinary systems, this is what we generally are using in our low seismic areas. Michigan, very, very common. We can space our reinforcement up to 10 foot on center. And so, in this part of the country, that's often not seen, not really heard of, not commonplace. But as we work in lower seismic areas, seismic design categories A, B, and C, we can take advantage of this, and we can space reinforcement up to 10 foot on center vertically. In terms of horizontal reinforcement, oftentimes we can just make our standard 9-gauge horizontal joint reinforcement at 16 inches on center work. And so all those come out of chapter 7. The reference here, so this diagram comes out of a book developed by the Concrete Masonry Association of California. Really, really good masonry book if you're looking to learn more about it. But they have really good diagrams on all that. As we look at differences between, again, ordinary, what I'm used to in Michigan, and kind of special reinforced masonry shear walls, what you see used generally in this seismic design category D area, they have a lot more reinforcement requirements, both vertically and horizontally. The big one here, horizontal reinforcement at 4 foot on center, or 1/3 the height of our shear wall, or 1/3 the length of our shear wall. So that means you have a lot more reinforced bond beams than what we'd see in Michigan. This comes up a lot because, especially as the industry is growing, engineers have more of a geographical reach. We're seeing jobs in Michigan that are designed by firms in California. And there was a school in Michigan where they used their special reinforced masonry shear wall provisions in Michigan. We were able to get rid of all of this, and it saved the job $240,000. Bond beams just aren't typical in my area of the world. They are down here. So it's really important to understand where you're at practicing at, kind of what those seismic requirements are. Additionally, so we have that horizontal bond beam bars, and you can see, again, 4 foot on center, and those need to be hooked around our vertical bars at control joints. You can see those 180-degree hooks here. And the one thing I did want to point out is in our new edition of TMS 402602, or 2022 edition, they got rid of that language. And so unless we have 40% or more of that shear capacity, we do not need to hook our bond beam bars around those vertical bars once that standard gets adopted. So that's something that can help save money, time on projects, not having to hook those horizontal bond beams. And so that is coming down the pipeline. 2022 TMS 402 will be in our 2024 IBC. So whenever that gets adopted here in Missouri. And you can see that here. If we have less than 40% capacity, or if our masonry is at less than 40% capacity resisting our shear loads, we don't need to hook those vertical bars. So that's a big code change that you're going to see coming in the next couple of years. After I've identified my seismic force resisting system, that kind of gives me broadly what my reinforcement size and spacing is. Oftentimes I'm working with the architect to understand our wall assembly. So what do we need from an energy code compliance standpoint? In Michigan, we're fortunate enough to be in 3 different climate zones. And so we are in climate zones 5, 6, and 7, depending on where we're at in the state. You can see this is our 2013 edition of ASHRAE 90.1, which is what we adopt for our energy codes and standards on the left. ASHRAE 90.1 2016, the maps have changed a little bit. We're seeing those climate zones sort of creep north as a result of more climate data that we have available. And so just because we were in a certain climate zone a couple of years ago, that has changed depending on where we're looking at in the country. But in this region, in the Midwest, largely we're in climate zones 4, 5, and 6. And so for that gym and office space, they wanted to use single width concrete block for the gym space. That's why they called. They didn't think we could make energy code requirements work with single width concrete masonry. But on the office side, we're able to use cavity wall construction. And so through ComCheck, we were able to show that 3 inches of rigid insulation on that office side, single width walls if we spray foamed our cores, we're able to pass ComCheck by 1%. Our building officials are generally just looking for a green box there in terms of ComCheck and energy code compliance. And so we went through and kind of identified all these things, and that's what ended up working on this particular project. So we used 3 inches of polyiso board in our cavity, 1 inch minimum airspace, brick veneer, and that was our wall assembly for that office area. And that got us to a U factor of 0.03. In our climate zone, we're allowed up to 0.09. So we're pretty comfortably below that from a wall assembly standpoint. The next thing is, once I kind of work with an architect and identify what does that insulation look like, we want to make sure that we're within the limits of our veneer ties. And so in our 2016 TMS standard, which is adopted here in Missouri in the St. Louis market, we're allowed a maximum dimension from our backup, whether it's concrete masonry, steel stud, or even wood, to the back of our veneer of 6 5/8 of an inch until we have to engineer ties. That number used to be 4.5 inches in 2013 and before, but now we're looking at 6 5/8 of an inch. So at 3 inches of rigid insulation, we had 1 3/4 airspace. We had about 5 inch between our backup and the back of our brick, and so we can make standard veneer ties work. And with a block backup brick veneer, far and away the most common veneer anchorage system we're going to use is what we typically call hook and eye wire. So you can see here we always have our horizontal joint reinforcement in that concrete masonry backup wall. That's functioning for shrinkage resistance. In that, they're going to weld these eyelets to that ladder reinforcement, and then we have these adjustable ties that go into it. This system is an order of magnitude cheaper than any other veneer anchorage system we're going to see. And so when I go through specs with architects, I really look for this, especially if we have a block backup brick veneer. Interestingly enough, before today's presentation, I had to help on a project, same exact wall assembly, but the architect had called out for tongue and groove edges on their rigid board insulation. Well, because of that one decision in their specification, that meant that they could not use standard hook and eye type joint reinforcement because obviously there's a tongue and groove situation there. And so it added about $35,000 to that small project just in veneer ties. When they got the bill for that, they changed their mind and went with just a standard flush cut insulation. But really, we don't need tongue and groove type joint insulation. Next, once we kind of have that assembly figured out, so I mean, we have requirements in IECC and our building code on vapor retarders and air barriers. And really, if we're using that hook and eye wire and we're using polyiso insulation in our cavity or polystyrene, as long as we seal the joints in that insulation, that system has been tested and meets our air barrier requirements. So if we're looking at cavity wall construction, instead of having to have a spray applied air barrier on the face of that block, as long as we seal the joints in that insulation, that has been tested, qualifies with air barrier requirements, saves quite a bit of money. In my market, spray applied air barriers, $10 to $15 a square foot. If we don't need them, if we can demonstrate air barrier compliance some other way, we can save quite a bit of money on projects. And so usually this is what we're doing in my market, sealing the joints between our insulation, that meets our air barrier requirements, hook and eye wire. Very, very efficient. There were other systems that were tested. So, for single width walls, like we had on that gym, obviously we don't have a cavity, but as long as we use a latex paint on the inside face of that block wall, that meets air barrier requirements. And so that's what we did for that part of the building. The big thing, when I'm looking at drawings with architects is we don't want to paint both sides of a single width wall because then that water is getting trapped in our wall, has nowhere to go, can lead to mold, air quality issues, things like that. But CMHA, they did a big study on air barrier requirements. And so if you ever want to know kind of how you can comply with them, reach out to Masonry Institute of St. Louis, reach out to me. We can certainly help point you in the right direction. Going then to kind of our notes. So, all of our notes on jobs refer to our TMS 402, which is our code for masonry building structures, and then our TMS 602. So we want to make sure that the contractor is constructing everything within our TMS 602 building specifications for masonry structures. The big thing here I oftentimes work with architects and contractors on also is sample panels. So we'll talk about this probably 3 times throughout today's presentation. But as we look at masonry materials, there is no workmanship standard. There isn't a workmanship standard for virtually any construction material we see. And so oftentimes, through the Masonry Institute of Michigan, I'll get a phone call at punch list time. We don't like the way something looks. The first question out of my mouth is going to be, where's the sample panel? In lieu of a sample panel, we do have tolerances in our codes. We have ASTM tolerances, but really there's nothing that kind of ties those things together. And so when I'm working with architects, I always encourage them to make sure we're using a sample panel at the start of construction, make sure the contractor, the architect, the owner are kind of always on the same page as far as what their expectation is for workmanship on that job. Next, specified compressive strength of masonry. So in Michigan, we have 15 different block producers. They produce a wide range of different materials. And so some of our producers make block that's 2,000 PSI. Some of them make block that's 3,000 PSI. And so in Michigan, largely, we recommend people stick with 2,000 PSI from an F''M standpoint. And that way it doesn't automatically negate any of our block producers from supplying the project. But this is a spot where it's really good to reach out to your local masonry association. So in terms of what that standard is, what that compressive strength is, really nobody knows the local market like your masonry association. So Bruce would be a great resource here in St. Louis. If you're designing jobs elsewhere around the country, there's a lot more masonry institutes out there as well that can kind of guide you in the right direction as far as what we should be specifying compressive strength-wise. The big reason this comes up, so in Michigan, oftentimes we'll see people specifying a block strength of 2,500 PSI, just arbitrarily. They don't need it structurally. That's just what they're specifying. Well, to get there, we need a block strength of 3,250. I can tell you 3 out of our 15 block producers in Michigan regularly make block that breaks at about 2,800 PSI. That means their submittal gets rejected on virtually every project. The problem is those 3 producers also make predominantly lightweight and medium weight units. And so we have contractors that bid jobs based on laying lightweight units, obviously lay a lot less, and then their submittal gets rejected, and so now they have to lay heavy normal weight units. And so there's this big issue with labor cost and kind of construction sequencing, things like that. And so again, I just recommend you reach out to your local masonry association. You kind of understand locally what's available in terms of block strength, and especially in high seismic areas, this does have a big impact on lateral load distribution in a building, and so it's good to understand kind of what's actually going into the wall. Mortar types, we have all this covered in our notes here. Generally, we're using a type S mortar for anything structural, pretty straightforward. Type N, as in November, we're usually using for veneer type units. When I'm working with architects in our market, I always try to discourage using a higher strength mortar in our veneers, mainly because it's an issue with cleaning. So if we have a dark colored brick, we're specifying a high strength mortar. It can be very, very hard to clean that surface, and they can actually damage the surface of that brick masonry. So really for anything veneer, we're at kind of type N. For anything structural, usually we're at type S. Sometimes we will see a note for type M, as in mic mortar below grade. And we have a whole bulletin on that, but for anything below grade, generally type S or M, as in mic, is appropriate. And so that's kind of what we have spelled out here. The other thing too, when it comes to mortars, is that there's 3 types of cement we can use: masonry cement, mortar cement, Portland cement lime. In Michigan, the east side of our state's all masonry cement, west side of our state's all mortar cement. I don't know why. That's just the way it is, but masons definitely have different preferences when it comes to types of cement and mortar. And so again, reach out to your local masonry association, kind of understand what is regional and what your mason contractors are used to specifying. The Chicago market, because I do some work there, they're largely Portland cement lime. In low seismic areas, it really doesn't make a whole lot of difference which one is used, so we kind of leave it up to the contractors what they want to use. The other thing, and I know Bruce is going to talk at the next one about testing, the Portland Cement Association, they did a whole bunch of, they looked at a lot of different testing companies, and I believe it was 93% of testing companies across the United States are incorrectly testing mortar. 55% of them are incorrectly testing grout. And so we funded some research 4 years ago now. The main issue is that testing companies obviously get paid by doing testing, so they want to do more testing, so they get paid more money. And so they make these 2x2 mortar cubes in the field, The ASTM standard says 3 times in the standard that this is not an acceptable means of evaluating compressive strength. Nobody reads that, nobody cares. So they make these cubes in the field, take them back to a lab, they break them, and now we have low mortar strength. Now we have an issue. So we funded some research at Brigham Young University, and we found that this field cube has about half the strength of the actual mortar in the wall. Our block units are going to absorb water out of that, and so the mortar in the wall has a much lower water content than what this cube will have that's usually cast in a brass or a plastic type fitting. So I deal with a lot of calls about low mortar strengths, and generally, I just don't lose sleep over them. They're following improper testing procedures. Usually it goes away, but if you're interested in any of this research, I'm certainly happy to share that. In terms of grout testing, usually they're using kind of a cardboard box, maybe cylinder mold, worst case scenario. In any case, they have to be doing correlation testing. Oftentimes that's missed, and so we have low block strength at 28 days. The problem is we have a lot of block laid up in 28 days, and now all that work is under question. So we need to make sure people are testing things correctly. I have a whole bunch of information on this, and I know Bruce is talking about it in the next one as well. In terms of joint profiles, so our notes say basically anything that's exterior needs to be either a concave finish, which is going to give us more of a watertight finish. So we'd be looking at the top left of this diagram here. That would just be our standard joint. Or else BIA does say we could use a V-type joint for anything exterior. Because when they're using those joiners, that's pushing that mortar into that joint. And so it gives us more of a watertight surface. If we want to do something like a flush joint or rake joint, you could do those interior, but really not recommended exterior. I should note too, so these are all our notes we developed through the Masonry Institute of Michigan. They've been reviewed through TMS, but I have all this stuff in Revit format, so if you want anything that you see today, send me an email and I can send it to you that you can use on your projects as well. Grout materials, so again, F''M, we want to talk to somebody like the Masonry Institute of St. Louis, understand what F''M is required. Then our strength of our grout needs to meet or exceed the compressive strength of our units. So in our case, in Michigan, 2,000 PSI means we have a unit strength or a grout strength of 2,000 PSI as well. And if we have a grout compressive strength of 2,000 PSI, if we go to our TMS 602, it tells us how we need to test it. Again, 55% of testing companies are incorrectly testing this, but they're supposed to be testing it ASTM C1019. We've done a lot of research on this over the last 5 years, and if you're mixing low strength grout, you are really doing something wrong. Even when we screw things up, usually you're breaking 3,500 PSI. And so if you get low grout strengths, probably an issue with the testing. Grout needs to be placed by somebody who understands how to place grout in the wall. There are different associations that have accreditations on this. So we train a lot of our contractors in Michigan how to place grout in walls. There's limits on grout lift heights. And so most of our grout we're seeing in the Midwest, we're low lift grouting, so we're limiting our grout pours to 5'4". Although, especially if we're using self-consolidating grout, we could actually grout up to 24 foot. We just have to use cleanouts in our walls. This is an area we're trying to change in our code. So we did some research 2 years ago where we built a ton of wall panels, grouted them. I put electrical boxes in there. I put anything that we could screw them up, I could. We didn't vibrate the grout. We did kind of everything wrong. And we were able to show that grouting up 12'8", we had no voids in that wall, even if we didn't vibrate it. So we're looking at doing a more comprehensive study to see if maybe we can raise the limit of low lift grouting to 10'8", 12'8", something like that, and eliminate those clean out requirements. So that's something we're actively looking at, but right now here's kind of where we're at in terms of our code. Wall bracing, so this is a big thing, and through my business, I do a lot of wall bracing design for contractors. In Michigan and other areas kind of surrounding us, we're usually internally bracing our walls. So this building here, this is Jiffy Mix. If you buy that cornbread mix at the store that's light blue in color, this is where it's made in Chelsea, Michigan. And these walls were 30 foot tall, and we were able to do a wall bracing report for that contractor and show that we didn't need any external pipe bracing. Those walls were able to resist construction level wind loads just with the grout and reinforcement that was in them. And so this ended up saving quite a bit of money on the project. Originally, this project actually was supposed to be precast concrete construction. We shaved 6 months off of the schedule going with load-bearing concrete masonry on this job. And the big benefit here from internal wall bracing is obviously we don't have all the pipe braces coming down. That means if we have trades, slab on grade contractors, underground contractors, this isn't a big coordination item because now we don't have all that limit on site logistics. And so internal wall bracing is something we often see done. Usually our walls are designed for a 40-mile-an-hour wind speed. During construction, you can see our wall bracing sign here. But just good to have notes that kind of capture that. You oftentimes won't see engineers that do that type of work as part of their scope because it's means and methods. Really, it comes down to the contractor and how they want to build the walls. But good to have a note on that, kind of how they're supposed to be bracing the walls. Control joints, another big thing. And I'd say in terms of calls I take at the MIM, movement control joints is number one far and away the call I get the most. What does the code say? So if we go to the code, it says, hey, Mr. and Mrs. Engineer or architect, you have to provide provision for dimensional changes resulting from all these things. What does that mean? We have to put control joints and expansion joints in our drawings. And we did get some language added to our 2022 code. It says that movement joint locations are recommended to be shown in the drawings, because the main issue we often see is that we'll go to the structural general notes or the spec, and it says something like this. We want control joints at 25 foot on center. Figure it out. Well, what does that mean for openings? What does that mean for corners? Where does that 25 foot kind of start and stop? There's a lot of, ambiguity with general notes like that. And so often we're encouraging people to show them in the drawings. And if we go to our mandatory requirements checklist, at the back of our code book, it says movement joints indicate type and location of movement joints on the project drawings. So oftentimes, we're seeing architects mainly doing the expansion joints for their veneer system. Structurally, we're going to show the control joints for our concrete masonry backup, but we have to be clear about where those go. And also, I often point out here type. I'll show you some details at the end of today's presentation, but I was involved in one job in Michigan, school project. They had 4-hour fire rated walls. Their typical control joint detail was a 2-hour rated control joint. Nobody caught it. Walls got built. Fire marshal caught it. The contractor had to cut out every joint in that school and that 4-hour rated wall and repair them. So it's important coordination item, structural, architectural. Where are rated walls? Do we have enough fire rating with our control joints? Things like that. Joint reinforcement. So we already talked about hook and eye wire. Again, that's the most economical way for us to anchor our veneer to our concrete masonry backup. The thing that I see missed here, and NCMA or CMHA, they updated their technical note. If we have half-eye units, normally our block are 8 inches tall, 8 inches or 12 inches wide, 16 inches long. If we use half-eye units, 4 inches tall, we have to put joint reinforcement at 12 inches on center instead of 16. Why? Well, there's more mortar in the wall. We're going to see more shrinkage in those wall assemblies. More shrinkage, more opportunity for cracking. Oftentimes Whole Foods, those type of retailers, they use a lot of this type of construction. They'll use spec brick or whatever the local product is, 4 inches high. If they don't put enough joint reinforcement in, very high likelihood that's going to crack. And so I often see that getting missed, in architectural specs or drawings. So just something to keep in mind. We do have that in our note. If they're half-eye units, put them at 12 inches on center instead of 16. And the other thing too here is we want to make sure that we're using 9-gauge horizontal joint reinforcement. Master spec and spec link, they have two options: standard joint reinforcement or heavy duty type joint reinforcement. We see people pick heavy duty because it sounds a lot better than standard, but a heavy duty wire is 3/16 diameter. Very, very hard for us to fit in a 3/8 inch mortar joint. And so unless we need it for shear reinforcement or for some seismic type reinforcement, 9-gauge joint reinforcement is typically where we're going to be at. Other stuff we have in our general notes, special inspections. I know Bruce has a presentation on this. In Michigan, we don't ever have special inspections. They are a minimum code requirement. They're just never enforced, which is a whole nother issue. But we want to make sure the people that are actually inspecting the project are qualified. ICC, they do have a qualification exam, and so the commentary kind of talks about that. But oftentimes when we're looking at special inspections on projects, there's a lot of confusion about kind of testing versus special inspections. And so testing companies will say they're doing special inspections, but they don't really know what they're doing, can lead to definite issues. So want to make sure it's done by someone who's qualified, so we have that in our notes here. We do have a note here on a 3-day curing period. And this came up, so the industry did some research onto kind of curing periods that we grout the wall, how long until we can apply loads to it. 3 days was kind of the general recommendation, so we do have notes on that as well. And I have all that research, if we wanted to go into that. But we do have that general note, so just kind of working our way through the notes here. In terms of reinforcement, so currently 2016 TMS 402602, we are limited to grade 60 reinforcement. In our 2022 code, we do have provisions for GFRP, glass fiber reinforced polymer reinforcement. And so if you wanted to take advantage of that, once you adopt that standard, you could. And we're actually looking at right now in our 2028 code cycle, high strength reinforcement. So I believe grade 80 and grade 75 reinforcement. So that's coming down the pipeline, but right now everything's kind of grade 60 as far as what we're looking at from a reinforcement standpoint. Another question I often get, so our TMS 602 says this: support reinforcement to prevent displacement caused by construction loads or by placement of grout beyond the allowable tolerances. Oftentimes we see rebar positioners being specified, just a piece of wire that hooks around, keeps that rebar in the center of there. It's not a minimum code requirement. In Michigan, we're generally low lift grouting, and so we often don't recommend using rebar positioners because it's relatively easy for a contractor to get the reinforcement in the right spot. And depending on what rebar positioner is specified or used, it can actually create an obstruction to grouting. Just something to be aware of. Make sure that everything's kind of fitting together. Lap splices, usually that's something we're going to see in our structural drawings. There's an equation in our TMS 402. Basically, if we have a number 5 bar, we have a 20-inch lap requirement in an 8-inch block. Again, we have schedules on this available in Revit. So, if you want copies of all these rebar schedules, lap splice schedules, I can share them with you, use them on your projects. We did do some research. We talked a little bit about wall bracing. If we're designing a wall to be internally braced during construction, we're building this big cantilever wall up, we don't have a roof connected to it, that base condition is really, really important. And so our wall bracing standard says that it needs to be 48 bar diameters for a lap splice. 48 bar diameters for number 5 bar equals 30 inches. And so this is an RFI we see a lot in our region where contractors want to take advantage of internal wall bracing. The engineer has this schedule in their drawings. They need to make sure that the engineer is okay with a longer lap splice. We did do testing on this down at the University of Louisville and showed that these lap splices were fine for internal wall bracing, but we're kind of working through the code part of that and getting things updated right now. But somewhere we need to tell the contractor what our lap splice requirements are, kind of where they go. Kind of along with that, bond beams. Again, for ordinary reinforced masonry shear walls, for things like this project, we're just going to have bond beams at our diaphragm level. And often if I have a bond beam at my roof or floor line, I'm going to put my reinforcement continuous through my control joints. And so I'd use a detail similar to this, and usually I'd debond it for maybe a foot on each side of that control joint, but I'm using that reinforcement as my diaphragm cord reinforcement. So it's imperative that this is continuous through here. If you have a special reinforced masonry shear wall, you could terminate it at your control joints, but usually at floor or roof lines, we want to make sure we're continuing our bond beam reinforcement through there. To make it look the same, usually I'll have them rake out the joint on either side, fill it with backer rod and sealant, so it looks just like the control joint in the wall, but all that grout and rebar is going through there. Going kind of through our specs then on this project. So again, we talked about special inspections, we talked about testing companies. One thing that I don't see done enough on projects is a pre-construction meeting. And so oftentimes in our specs, I require pre-construction meetings between architect, engineer, mason contractor, testing agency, special inspection agency. If we're not all on the same page at the start of a project, that's where we kind of see things go awry. And so we do have an agenda on this available. So it's something I often encourage in specs, and we have an agenda that you can use, on your projects as well for pre-construction meetings. Talked about sample panels. So this was a sample panel on a new cancer institute up in Michigan. A lot of different types of units, colors, things like that. And so we wanted to make sure that we had a clear understanding of what the required appearance was here. And so oftentimes when I'm specifying sample panels, I want the contractor to put everything in there that's going to be in the wall: flashings, air barriers, end dams, all those things that I can make sure that they clearly understand what my design intent is as a designer. And so I usually make them make their sample panel as a separate piece of the building. You could make it part of the building if you wanted. Just make sure you're clearly showing where that is in the project drawings. Going through our specs also, so we do have performance requirements. Delegated design, I don't have a slide on here, but that is something we're seeing a lot of kind of in Michigan. Usually it's veneer anchors. We're allowed 6 5/8 of an inch cavity If we exceed 6 5/8 of an inch, somebody needs to engineer those ties. So that's usually a delegated design item we'll see. In Michigan, we have seen a lot of architects start looking at delegating out interior partition wall design on jobs. And so, I mean, they don't necessarily have the fee to do it in-house. They'll delegate it out to the contractor. Contractor hires an engineer. We submit stamped shop drawings. We were just able, I got an email yesterday, we saved $237,000 on our job by delegating out partition wall design to a contractor in Michigan. So we are seeing that a little bit. The other thing that comes under performance would be our fire rated assemblies. In terms of masonry and concrete construction, generally we're achieving fire resistance ratings by what we're calling the calculation procedure or our equivalent thickness method. So if we take this unit here, we recast it as a solid unit, how thick would it be? And there's tables in our IBC that kind of correlate to what those fire resistance ratings are. But oftentimes I'll see specs call out for a UL rated assembly. Most of our block producers have not undergone UL testing, and so they can't directly demonstrate fire resistance rating through UL. So we're looking at that equivalent thickness method. For all of our 8-inch block in Michigan, and I think largely throughout the country, we're getting a 2-hour fire rating, hollow, no grout in it. 12-inch block, typically we can get 3 to 4 hours fire rating, hollow, no grout in it. But the big thing here is oftentimes as we look at units, producers are going to taper those face shells and webs of those units. And so our ASTM standard is going to say this needs to be a minimum of 1.25 inches face shell thickness. This would be the bottom of our unit here coming out of the mold. It's going to be much, much thicker on the top of it. So usually, in our market, they're going to flip them over to have the thick side up in a wall, but they are not just a standard 1.25 inches, from top to bottom. Other things in our specs, all of our concrete masonry units fall under ASTM C90, which covers lightweight, medium weight, normal weight. Michigan, we have very little access to lightweight aggregate, and so largely we're predominantly normal weight. In this market, I'm not familiar with all the aggregate suppliers, but Masonry Institute of St. Louis will be able to kind of point you in a good direction as far as what's available. We can get lightweight aggregate into Michigan. It's just very expensive for us to do. And so it just drives up project cost unless we need it for something. Textures, burnished block has been all the rage lately, so we do see a lot of burnished block used on projects. Brick, so all of our clay facing brick falls under ASTM C216, and so where we're at, we're severe weathering, so we're calling out for grade SW, and usually we're calling out for type FBS, which would be face brick standard, unless this is a picture from that same Cancer Institute where everything's laid in vertical stack bond construction. So on this project, they called out for type FBX brick because they wanted to maintain a little bit tighter tolerances on their brick to make sure they had clean joint lines all the way up that wall. So type FBX brick would have tighter tolerances here. And usually we're seeing kind of, utility or modular brick being used kind of in our market. Mortar and grout materials, we talked about this. In Michigan, a lot of our contractors site mix mortar and grout. That's not the same around the country. So down here, I believe it's a lot more pre-blended. But in Michigan, we can use anything, masonry cement, mortar cement, Portland cement lime. And so we allow mason contractors to kind of pick whatever they're used to, unless they're in seismic design categories D, E, or F. We talked about joint reinforcement. So single withe masonry, we want to make sure we're using ladder type joint reinforcement. Looks like a ladder, so that way our horizontal wires line up over the webs of our unit. We don't have anything obstructing our grout flow. As I look at jobs around the country, I still see a lot of architects specifying truss type joint reinforcement, which was mainly used when we had unreinforced masonry. So, ladder type joint reinforcement is really where we want to be. And if we have a cavity wall, we're going to use that hook and eye wire. And when we're using that hook and eye wire, we should see this where those eyelets are lining up kind of near a head joint. That's telling us that that wire is right over the web of a unit behind it. Flashing, so for that job in Kentucky, I helped the architect choose the flashing there. We just went with a peel and stick flashing, self-adhering on that job. So we see a lot of different flashing materials used kind of around the country. In Michigan, I'd say 90% of our market, maybe 80% of our market is a self-adhering rubberized flashing. That's generally what we see. There's a lot of really good stainless steel self-adhering flashings available now that are S304. Those get used pretty widely. You can see that here in the bottom right. And a lot of our contractors, they take like a floor roller and they'll roll out any of the wrinkles in that. And so it gives us kind of a nice surface for that flashing. Those are commonly what we'll see. And oftentimes when we're working with architects in Michigan, one of the things that we have, so we have a metal drip edge that we're calling out to terminate the top of our vertical leg of that a termination bar up there. But for a metal drip edge, we've seen a lot of issues, especially on school projects in Michigan, where at our base flashing, we'll have this exposed metal drip edge sticking out of the wall, and it creates this really sharp condition at an outside corner. And so a lot of our architects in our state, they've moved to just using a 180-degree hem drip edge only at the base of our wall, so that way we're not creating any sort of hazards to pedestrians. It's not an issue if you do it right, but we do see that in our market, that at the base flashing only, we're kind of using that 180-degree hemmed drip edge that sits flush with the face of our wall, doesn't project out. Termination bar, again, that's what we're generally seeing used to terminate the vertical leg of our flashing up here. The reason for that, we still see some specs that call out for this vertical leg to be tucked into that bed joint. Problem with that is we have to put the flashing on the wall when we build the backup wall. And then we might leave the job site, come back 2 months later to lay up the veneer. If we use a termination bar, we can put that flashing on pretty close to when we're laying up the veneer. A lot of these materials, especially the asphaltic flashings, are very UV sensitive. So we don't want them sitting out there for a couple months, kind of exposed to sunlight, things like that. The other thing too, so we call out for cavity drainage material. This particular product here is called mortar net. They're pretty common throughout the US, but there's a lot of different manufacturers on it. I have measured all these products, and all these products are 10 inches tall, which doesn't really matter for a whole lot of reasons, but their intent here, so they're dovetail configuration. So if mortar falls into the cavity, we still have active drainage through these diagonal teeth, whatever. So we can get active drainage here. But, I've looked at some walls where if we don't have insulation in the cavity, this sits up 10 inches. A lot of specs call out for that vertical leg of our flashing to only go up 8 inches. We go up 8 inches, we terminate it, we put a bead of sealant between our termination bar and our wall. Well, if this is up 10 inches and we have a bunch of mortar and debris up there, if we get a sealant failure, we can get water getting behind our flashing. And so as long as that flashing is behind something, insulation, some type of barrier, usually not an issue. But if we have a situation where we have our flashing in direct contact with that mortar net, I'll usually have them use a longer leg on that flashing just to get it up above that 10-inch, drainage material. Board installations, we see a lot of jobs, cavity wall construction, using both board and closed cell spray foam insulation. I believe board insulation, at least in my market, is relatively cheaper. The thing with board insulation that we have to be a little bit careful with is NFPA 285. We don't want the cavity catching on fire, fire going up the cavity, catching other floors of our building on fire. And so we have all our details on our website that have been tested and are NFPA 285 compliant. And the way we mainly did that is we wrap our openings with mineral wool or something more flame retardant, and then we'll use our board insulation, and that helps prevent that board insulation from igniting, going up our cavity. For single-story construction, doesn't really matter, but if we're looking at multi-story construction, NFPA 285 does have bearing and something we got to consider. So generally in our market, we're seeing either XPS board or polyiso being used. Closed cell spray foam, we see a lot of K-12 architects using because it qualifies as an air barrier and a vapor retarder. But a lot of them, this material can get hot when it cures, and so they want to protect their flashing. So usually they'll put a piece of rigid insulation to protect their vertical flashing, vertical leg of their flashing, and they'll spray up from there. Nothing wrong with the product, just kind of depends on who's designing it. We talked about this, so this is 10 inches tall. We want to make sure that our flashing is beyond that if it's in direct contact, so that's in our spec language. On this project, we talked about this. So again, this is that 180-degree hem drip edge we see used in our market just at the base of wall condition to prevent, again, a sharp corner from forming. And so, that's just something we see. Sometimes we'll see, in the Ohio market, especially in Toledo, they'll just cut the flashing flush with the face of the wall at the base location. Geographically, it can kind of be different depending on, who's doing the work or what they're kind of used to. But that's what we see in our market, 180-degree hemmed drip edge at the base of our wall. So that's what we did there. And then kind of going through some drawing standards and things that, pertain to this particular job in Kentucky. We're typically just bearing our joists, beams on our masonry wall, so they will pocket that out. And so we had a bearing plate called out here. If I had to change one thing on this job, we had our top of steel at 113.3, and we had 5-inch joist seats here. So that means that our bearing plate is not on an 8-inch module. I mean, it just was the way the geometry of the project worked out. But, you know, I mean, if we can get our bearing location to line up on an 8-inch module, that saves a lot of cutting of units. And so, you know, that's something we generally want to do. The other thing too with our bearing plates, and I'll show you a detail of what I generally kind of do, but we want to make sure that we don't create issues with having a soap or a face shell beyond that bearing plate, and we'll kind of get into that a little bit. For our non-load bearing walls, you know, typically I'm just using a angle iron that's going to support my roof deck, and then I just use quick bolts or something to connect that to my masonry wall. The one thing here that I often see in drawings, so any 8-inch block wall I'm usually designing, I use 1 bar in my bond beams. Why? Well, especially at corners, if we have 2 bars in an 8-inch block wall, then we have our bent bars going around the corner, and we have our vertical bars coming up at that corner, we have a whole lot of reinforcement right at that one location. Could be an issue for grout consolidation depending on what we're looking at. So generally, I'm just trying to use 1 bar in my 8-inch block walls if I can. And this is a masonry elevation I put together. So the nice thing here when we're using Revit or some of our other software, I can actually model my angles and my deck so we can see our low slope roof here. So I can tell the contractor exactly where I need to step my bond beams to make sure that when I'm bolting into that wall, I'm always bolting into a fully grouted course. So I mean, that's just a nice thing we can do in our masonry elevations to really show the contractor what our expectations are. For this job in Kentucky, you know, I used Masonry software, which is developed by CMHA. And so, I mean, we really only needed reinforcement at, I think, 72 inches on center. But for internal wall bracing, and because of the configuration of it, we actually ended up with a reinforcement spacing somewhere about 56 inches on center. And so for that case, 76% capacity. And so, I mean, if we have this wall panel here, 20'8", I'm telling them I want number 5 vertical in there. And again, I mean, through masonry wall elevations, we can convey that information very, very clearly. And this helps me locate all my control joints as well, you know, which are shown in those elevations. Masonry will not do openings in walls. And so what I do, you know, and there are softwares that do that. I'm cheap, so I don't pay for them. But I'll look at this wall segment between openings and I'll just apply a larger tributary area wind load to that. And so in this case, we had whatever it was, 4 foot, you know, between this garage door opening here, this man door here. So I apply a larger wind load to that. I have 3 bars in there, and I can show that that's still at 54% capacity. And so oftentimes, you know, what we'll find is that if we're just looking at per foot of wall, that's one thing, but when we're actually looking at a full wall segment, oftentimes we have way more reinforcement in there than we probably even, you know. So again, I mean, this is what I generally do for wall elevation. So I'm showing all my lintels, dimensioning out all my openings. The other nice thing is too, if we model all of our roof steel, we can make sure that we don't have a joist bearing on a control joint. And so this helps me locate those control joints away from my openings, away from my joists, make sure that we have a nice layout for both our vertical reinforcement and our horizontal reinforcement. So you can see all that kind of here. So I mean, those are just things I do, you know, from a coordination standpoint. Again, if we're looking at distance between control joint and end of wall, 29% capacity, you know, we're good to go there. So I mean, we didn't end up needing a whole lot of reinforcement on this project. This would be a bearing wall. You can see my roof joists here bearing on that wall. Again, 72, I think, inch on center spacing. Which with an ordinary reinforced masonry shear wall, we can go up to 120. So we were good there. Interior walls, you know, I mean, again, you can see we didn't need all that much reinforcement on this particular gym project or therapy kind of center. A few of the standard details I wanted to touch on as well. So, I mean, you can see this typical control joint here I have called out in my drawings. This would be what we would call a formed paper control joint. So we take eared block, we butt them up together, and then we fill that void between the eared block with grout or mortar. I always use this detail because it's 4-hour fire rated. So I don't really care where the rated walls are architecturally. I know that my joint is always going to have a 4-hour fire resistance rating. If you use a gasketed joint, it gets a 2-hour fire resistance rating. Might not matter, but you know, I have been involved on projects where it's been a pretty big deal. So this is kind of standard what I'm doing. They cut the joint reinforcement at my control joint. We put building paper between our grout and the ear of that unit, and then again fill it with grout or mortar. As far as wall intersections, I mean, this would be my typical joint. So this is just a piece of like basically chicken wire mesh. And so the code has a couple different ways of handling these conditions. This is what I generally use. Sometimes I'll see a standard detail where there's this stainless steel strap anchor that sticks out of this wall like 24 inches, right at eye level. So, kind of a safety concern. That's required if we have a flanged shear wall. Most of our software that we use structurally does not design flanged shear walls. And so that detail with this giant stainless steel strap anchor sticking out of the wall, very, very rarely required. And so oftentimes this is what we're using, just a standard mesh type anchor at our wall intersections, 16 inches on center. In this case, I often advocate for taking our block down all the way to our foundation. So that's what we did here. So this would be our single width part of our wall. We took that block down to the top of our foundation. I forget what the frost depth was in Kentucky, but I dropped it by 2 inches. So that way this was a nice module of 8. And so it let me keep my 1 foot to concrete footing here. And that lined up nice with an 8-inch module. Same thing if we look at our cavity wall here. And so again, we're going to grout below finished floor in this cavity. We'll flash out here in our wall. Pretty straightforward. In Michigan, sometimes we'll see people using concrete stem wall, but if we already have masons on the job, oftentimes it's, can be quicker, easier just to use masonry all the way down. Bearing plate details. So, this comes up occasionally. I always offset my bearing plates 1/2 inch from the face of my block intentionally. That way, if this roof joist deflects under snow load or whatever load, it's not cracking that corner of the block. So, that's just a drawing detail I've used for a long time. SJI, our Steel Joist Institute, they do have a 4-inch minimum bearing length on joists. So that's what I have called out here. Where that becomes an issue is interior walls. So this job, again, had 8-inch block walls, an interior block wall, 7 5/8 of an inch wide for an 8-inch block. And so to maintain that 4-inch minimum joist length, I had them offset these joists next to each other and just specified a little bit wider plate. You could ask them to use a shorter joist seat. I've done that before too, but I was involved in a couple jobs where an engineer took this requirement a little too seriously, and so they had 8 million different bearing plates because of that 4-inch offset, and made it tough to reinforce and grout. So those are just kind of some typical details I'm using. Again, we have all this content available, if you want to use it, but that's basically what we did for designing that project. We always use masonry lintels, and so on this job, just standard 8-inch CMU lintels. We had 2 number 5 bars in them. For our larger openings, we did have an open bottom bond beam unit up here with top reinforcement, and so that ended up working. And then we just had a loose lintel down here carrying our brick. If we have wider openings, I have used things like a ferro fast bracket here to carry the brick, supported on our backup. That way we don't have a thermal bridge through our wall system. There's different ways of handling that. I have actually had them put joint reinforcement in brick veneer before to actually design a reinforced brick beam over an opening, because we didn't want to have the thermal break from an angle that gets bolted to that backup. So we've done that before. There's lots of different solutions depending on kind of what our opening width is. But with that, that's generally kind of my approach to jobs. That's how we handled this Kentucky project. We got 5 minutes. I'm happy to stay here as long as anyone wants. My contact information, best way to reach me is email. But thank you for your time, and I guess who's got some questions? Yes, sir.
For your internal wall bracing option, are you having to increase footings or
I have not had to. So the benefit is, so the question was about internal wall bracing and foundation overturning. In Michigan, we have a frost depth of 42 inches. And so it's nice for us because whenever I look at foundation overturning, it's usually a moot point because we have passive pressure acting on it. If we have an interior wall with just like a footing that's down 8 inches, that has been an issue, and we've had to look at ways of solving that. But yeah, good question. Other questions?
What do we think? Was that the best way to start the season or what? The last thing I'm going to ask Phil to do for us is to pick our business card drawing for the Basics of Masonry book and the Ledent design hat.
Yeah, Will Hammond.
All right, well, thank you all so much. Check your emails. You'll get a survey and a certificate. If you don't,